how we visualize a problem or a goal in our mind has everything to do with how we lean into that goal, whether or not we think of it as overwhelming or tractable, whether or not we think that we can overcome that goal and then it will lead to yet more possible rewards and goals, or whether or not we feel that we're going to arrive at the finish line and then just be overwhelmed with fatigue.
Andrew Huberman delves into the science behind habit formation and shares 3 powerful strategies to become more successful in life.
I always say, and here I'm strongly biased as a vision scientist, that vision is the dominant sense by which we navigate the world and survive. I love this idea of real-world, real-time access to vision, and I'm certainly familiar with how goal setting or Post-its and magnets on refrigerators can have an immediate impact, but then over time they become so part of the visual landscape that you overlook them. And we know as vision scientists, if something is stably in your environment, eventually you're blind to it. So that makes good sense. Habits organize our behavior into more or less reflexive action, so we don't have to think too much about performing the various behaviors that, for instance, allow us to brush our teeth or which side of bed we roll out of in the morning. And then, of course, habits can be more elaborate too. We can be in the habit of exercising at a particular time of day. We can be in the habit of eating certain foods. We can be in the habit of saying or not saying certain things. So by ingesting caffeine pretty regularly, you're actually increasing the ability of dopamine to have this effect of increasing motivation and drive. I tend to ingest caffeine only early in the day. I tend to cut off my caffeine intake somewhere around 1 or 2 p.m. to ensure that I can get into a good night's sleep. But I realize that there are people out there that ingest caffeine as late as 2 or 3 in the afternoon and can still sleep fine. I will caution those of you that think that you can drink caffeine in the evening or nighttime and still fall asleep. All of the research points to the fact that the architecture of your sleep and the depth of your sleep is disrupted. Even if you're able to fall and stay asleep, the sleep you're getting is simply not as good as the sleep you would get if you were to shut off your caffeine intake at least 8 hours before bedtime, and ideally more like 10 or even 12 hours before bedtime. But of course, there are practical constraints as well.
Huberman discusses procedural memory and its role in habit formation. He introduces a simple visualization exercise to help people build and maintain new habits effectively.
Talk about the most basic ways that we learn and remember things and how to improve learning and memory. And the most basic one is repetition. Now, the study of memory and the role of repetition actually dates back to the late 1800s, early 1900s, when Ebbinghaus developed the first so-called learning curves. Now, learning curves are simply what results when you quantify how many repetitions of something are required in order to remember something. In fact, it's been said that Ebbinghaus liberated the understanding of learning from the philosophers by generating these learning curves. What do you mean by that? Well, before Ebbinghaus came along, learning and memory were thought to be philosophical ideas. Ebbinghaus came along and said, well, let's actually take some measurements. Let's measure how well I can remember a sequence of words or a sequence of numbers if I just repeat them. So what Ebbinghaus did is he would take a sequence of numbers or words on a page, and he would read them, and then he would take a separate sheet of paper, and we have to presume he didn't cheat, and he would write down as many of them as he could, and he would try and keep them in the same sequence. Then he would compare to the original list, and he would see how many errors he made. And you do this over and over and over again, and as you would expect, early in the training and the learning, it took a lot more repetitions to get the sequence correct, and over time, it took fewer sequences. And he referred to that difference in the initial number of repetitions that he had to perform versus the later number of repetitions that he had to perform as a so-called savings. So he literally thought of the brain as having to generate a kind of a currency of effort. And he talked about savings as the reduction in the amount of effort that he had to put forward in order to learn information. And what he got was a learning curve. And you can imagine what that learning curve looked like. It was at a very sharp peak at the beginning that dropped off over time. And of course, he remembered all this meaningless information. But even though the information might have been meaningless, the experiment itself and what Ebbinghaus demonstrated was immensely meaningful, because what it said was that with repetition, we can activate particular sequences of neurons, and that repeated activation lays down what we call a memory. The study of memory is one that dates back many decades, and by now there's a pretty good understanding of how memories are formed in the brain, the different structures involved, and some of the neurochemicals involved. Memories are not just about learning. Memories are also about placing your entire life into a context. And that's because what's really special about the brain, and in particular the human brain, is its ability to place events in the context of past events, the present, and future events, and sometimes even combinations of the past and present, or present and future, and so on. So when we talk about memory, what we're really talking about is how your immediate experiences relate to previous and future experiences. I know many of you will read or will encounter programs that are designed to help you enhance your memory. You know, you have these phenoms that can remember 50 names in a room full of people, or they can remember a bunch of names of novel objects, or maybe even in different languages. And oftentimes that's done by association. So people will come up with little mental tricks to, either link the sound of a word or the meaning of a word in some way that's meaningful for them and will enhance their memory. That can be done and is impressive when we see it. And for those of you who can do that, congratulations. Most of us can't do that, or at least it requires a lot of effort and training. However, there are things that we can do that leverage the natural biology of our nervous system to enhance learning and memory of particular perceptions and particular information.
Task bracketing, a neural process within the basal ganglia, becomes the focus. Huberman explores how task bracketing influences habit context, strength, and adaptability. By considering the events before and after a habit, you can shape your neural imprint, making habit formation and persistence more effective. Rewarding both the habit and task bracketing aids in achieving your goals.
The question I often get is, how long should I try to focus? Well, the research literature point to the key importance of so-called ultradian cycles. You've all probably heard of circadian cycles or circadian biology. Circa, the day, circadian, is about 24-hour cycle. Well, our brain and body operate within that day, or within each and every day, I should say, with 90-minute ultradian cycles. So my suggestion would be, anytime you're going to sit down and try and focus, you're going to try and do a focused bout of physical exercise or skill learning or musical learning, or maybe you're even just having a conversation. Maybe you're a therapist or you're attending therapy or a class. How long should it be? And the ideal duration is about 90 minutes. Not exactly 90 minutes, but we can reliably say 90 minutes or less. Okay, it doesn't have to be the full 90 minutes, but trying to push yourself to be able to drop into 2 hours of focus or 3 hours of focus while possible is not really in line with what we know about the underlying biology. Everything from our sleep states, or the different stages of sleep, and our waking states is divided into these 90-minute cycles, or so-called ultradian cycles. So what I like to do is set a timer for 90 minutes. I acknowledge and accept the fact that under most conditions, unless I'm really pressed for a deadline and I'm optimally caffeinated, etc., the first 5 to 10 minutes of that 90 minutes are a transition time. It's like the warm-up for focus, but I do include it in that 90 minutes. And then I really try and drop into doing focused mental work or learning of some sort. Again, this could be physical as well, motor skill learning, or I think we're running or lifting weights, etc., and really try and drop into that across the full 90 minutes, again, accepting the fact, okay? It's not just an idea, the fact that occasionally our focus will flicker. It will jump out of focus, and then a big part of being able to focus is to go back to focusing. The way I'd like you to conceptualize this, perhaps, is that arrowhead suddenly getting very, very broad, that you're focusing on many things, or that arrow shifts to a different location in the room. The key is to be able to shift it back and to narrow it once again, and that's an active process. So much so that it requires a lot of metabolic energy. Your brain is the chief consumer of metabolic energy. The calories that you consume is so-called basal metabolic rate. Most of that isn't related to movement or heartbeat or breathing. It's related to brain function. Your brain is a glutton with respect to caloric need. So understand that at the end of 90 minutes, or maybe even after 45 minutes, you might feel rather tired or even exhausted. And it's very important that after a bout of focus, that you take at least 10 minutes, and ideally as long as 30 minutes, and go through what I call deliberate defocus. I wake up in the morning and I want to reach for my phone. But I know that even if I were to crank up the brightness on that phone screen, it's not bright enough to trigger that cortisol spike and for me to be at my most alert and focused throughout the day and to optimize my sleep at night. So what I do is I get out of bed and I go outside, and if it's a bright, clear day and the sun is low in the sky, or the sun is starting to get overhead, what we call low solar angle, then I know I'm getting outside at the right time. If there's cloud cover and I can't see the sun, I also know I'm doing a good thing, because it turns out, especially on cloudy days, you want to get outside and get as much light energy or photons in your eyes. But let's say it's a very clear day and I can see where the sun is. I do not need to stare directly into the sun. If it's very low in the sky, I might do that because it's not going to be very painful to my eyes. However, if the sun is a little bit brighter and a little bit higher in the sky, sometimes it can be painful to look at. So the way to get this sunlight viewing early in the day is to look toward the sun. If it's too bright to look at directly, well, then don't do that. You just look toward it, but not directly at it. It's absolutely fine to blink. In fact, I encourage you to blink whenever you feel the impulse to blink. Never look at any light, sunlight or otherwise, that's so bright that it's painful to look at because you can damage your eyes. But for this morning sunlight viewing, it's best to not wear sunglasses. That's right, to not wear sunglasses, at least for this morning sunlight viewing. It is absolutely fine to wear eyeglasses or contact lenses, so-called corrective lenses. In fact, those will serve you well in this practice or this tool because they will focus the light onto your neural retina and onto those melanopsin intrinsically photosensitive ganglion cells. If your eyeglasses or contact lenses have UV protection, that's okay. There's so many different wavelengths of light coming from the sun, and they are bright enough that they will trigger the mechanisms that you want triggered at this early time of day. So try and get outside, ideally within the first 5 minutes of waking, or maybe it's 15 minutes, but certainly within the first hour after waking. You know, when you narrow your visual window, you're measuring, the time bin also gets smaller, right? Which makes sense when you hear it. Whereas if you take on a huge visual landscape, you're actually carving up time differently. It's sort of like moving from a slow frame rate to a fine frame rate. You know, slow motion camera is actually taking a lot more snapshots, right? So you're measuring distance over time more finely. And so whereas strobe would be the other example, which is strobe is very low frequency. So you're going here, 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 as opposed to, you know, slow motion, right? Strobe gives a coarse view into the time domain, and high speed photography gives a fine view in the time domain. So I'm almost certain, without any knowledge of underlying data, but knowledge of the mechanism, that I'm almost certain, if not certain, that by placing a narrow visual aperture, we change the way we perceive time.